Good afternoon, everyone, for joining us from different parts of the world. A very warm welcome to day three of the fifth International Conference on Universal Threats in Expert Applicants and Solutions, or as we fondly call it, UNI-TEAS 2026. I am Harshita, and it's an absolute pleasure to moderate today's online session. This prestigious conference is being organized by Shree KKarni University College, Apex University, and Panipat Institute of Engineering and Technology, managed by KK Consultancy Services India, and supported by University of Rajasthan, ACM Jaipur chapter, All India Council for Technical Education, and Computer Society of India Jaipur chapter. This year, we received an overwhelming response with over 300 paper submissions from across the globe. After filtering out AI-generated and plagiarized content and a rigorous peer review process by our expert panel, only the top 80 papers were selected for the presentation. Based on their performance and the recommendations of our session chairs, these selected papers will be published by the Springer's Nature. Day 1 of the conference, which was 16th of February 2026, we had an incredible series of keynotes, paper presentations, award ceremony, and discussion that truly embodied the spirit of innovation and inclusivity offline in Jaipur. As we step into day 3, we carry forward the same enthusiasm, ready to dive deeper into the thought-provoking session and interactive presentations that will continue to shape the future of intelligence system and digital security. With that, I'm pleased to introduce our session chairs for this segment. Session Chair Ashish Kumar Singhal, Associate Professor from Sagar Institute of Science and Technology, Bhopal. Session Chair Reena Dadhich, Dean Research from University of Kota, Kota, Rajasthan. Session Chair Akhilesh Kumar Sharma, who is a professor in Manipal University, Jaipur. Before we proceed further, I would like to share a few important instructions for all the paper presenter to ensure a very smooth and timely session. First, each presenter has 10 minutes to present. Please stay within the time limit. Briefly cover your research context, objectives, methodology, key findings, and conclusion. Second, a short Q&A may follow your talk of 1 to 2 minutes. Keep responses very brief and focused. Next, keep your mic muted when not speaking. And last, stay for the full session to support the fellow presenters. And with the kind permission of our session chair, we would now like to proceed with the paper presentation. Shall we start, ma'am and sir?
Yes, ma'am.
Yes, I only joined as a session chair in this session. If you are able to see the meet,
Yes, ma'am.
then
Should I call the session chair?
event organizers, you are organizing the session, no?
Yes, sir. Yes, ma'am. Just wait a minute. I'll call them. Reena, ma'am, fellow session chair will join us in a few minutes. So shall we start?
Yes, start.
I would like to invite the first presenter for the day, presenting the paper titled Intelligent Pest Management System Integrating AI and IoT Advancing Smart Crop Protection under paper ID 445. I would like to I would like to call Mr. Rajgor Viral Naveen Bhai to present the paper and take on the virtual floor.
Okay. Is that audible, madam?
Yes, sir, you
Yes,
are.
audible.
Okay. Good afternoon, ma'am, and all the dignitaries. I'm very thank you, UNI-TEAS team, to give me opportunity. My topic, my research paper or topic of intelligent pest management system integrating AI and IoT advanced smart crop protection. Myself, Viral Rajpur. I'm a research scholar at Department of Computer Science, Saurashtra University, and right now I'm working in Kutch University as a software programmer. So here is Okay, here is some outlines of today. First of all, I will start with introductions. After that, literature review about which kind of research paper I have already read. Then after research gap, objective, proposed solution, tools and technology. So this will be the outline of my today's session. So first of all, I start with my introductions. That what is problem. Like as you can see the graph here, 25 to 30% is annual crop loss in India right now. So this is a cause of problem. So that's why the crop storage, even homes are badly damaged by birds and wild animals. But eat grains and fruits while wild animals destroy the field, sometimes enter the storage area. Because of this, farmer lose crops and money. Food production decrease and crops yield become a low, and farmer face financial problem. So traditional method. Okay, here is some traditional methods. Like south stick waving, insect-proof plant pruning, chemical pesticides stored or mud walls. So that's all are the traditional method which are currently used. After some times, birds, animal gets used to these kinds of methods, so they stop being afraid. That is why these methods are not effective for a longer protection. To solve these kinds of a problem, this research proposed intelligent pest management system, and that uses the artificial intelligence and IoT for smart crop protection. The system is designed to scare away both birds and wild animals using different methods such as sound, flashing light, moving parts, water sprinkle, etc. So the system works on the solar power, so it can run continuous even if in the remote area also, where electricity is not available. It creates changing and the smart pattern like the distress sounds, predator sounds, blinking lights, moving objects, and control water spray. Because these patterns keep changing, birds and animals do not get used to do the same. This makes system more effective for a longer crop protections. Okay, literature review. I have literature review regarding current techniques of pest management, IoT-based crop protection system, like which kinds of sensor are being used in agriculture industries, animal detection technique via AI technology, like how can we detect a different kind of animal with the use of AI. Solar power technology, lots of solar powered are also being used in agriculture industry with that use. After that, for a data trans system, I have seen that kind of acoustic data trans with the use of bioacoustic solutions. From that use, sound is the way we can scary or the repellent the birds and wild animal. After that, optical deterrence. That's one kind of a laser light. It will also be more useful in means that kind of a research are too much. We can see kinetic deterrence and sprinkle based deterrence. So that's all are for different kind of deterrent systems. Okay, a research gap. Which kind of a research gap I found that uh, I have seen a lot of things, but with the combination of these three: solar power, AI, and IoT, I saw very much low and not much research on that topics. After that, a lack of multimodal and intelligence data system. I have seen single kind of intelligence data system a lot where time, but the combination of this multimodal, I haven't seen any research paper. I haven't seen any much research on that kind of a thing. So that the things which I want to do for that all. Insufficient animal behavior data and limited AI accuracy evaluation in the diverse environment. So the data set of these kinds of animal behavior data is too much low. So with that use of this research, it could be we can enlarge that kind of a data. Okay, so objective of this data is simply to make design an intelligent pest management system integrating AI and IoT, advancing the smart crop protection. This is what I have to use. Develop a multimodal data system. So that multimodal could be more helpful than a single layer to collect, develop a comprehensive data set for animal behavior pattern. So the data set which is not yet fulfilled, we could be more enlarged on that base of animal behavior patterns. Okay, propose solution. So this kind of things which is supposed to be make the solar panel and the mechanical arms, all that. Okay, so this is the block diagram of the proposed system. That energy systems, the energy system have both solar power and alternate solution also available. After that, the second part is sensing and monitoring. For sensing, there are different kinds of sensor like PIR sensors, ultrasonic sensor. This kinds of sensor are being used for monitor camera which will surveillance the animal also. For deterrence mechanism, we are having a total four different parts like acoustic deterrence, optical, kinetic, and sprinkle. These four are the different mechanism to make all that system. Okay, which kind of a tools and technology I've used? That sensor, motion, proximity, weather, and camera, LoRaWAN and ZigBee protocol I'm going to use. For Python and TensorFlow, that is for machine learning, SQLite, and for visualizing, I will use Graphene and Matplotlib. Okay, hardware component which is required, that solar panel, batteries, for sensing and monitoring, motion sensor, proximity sensor, weather sensor, camera, deterrence mechanism, actuator, speakers, LED lights, mechanical arm or movable parts, water pumps, sprinkle nozzle, water storage tank, valve, and pipes and hoses. Okay. So how I will make that research methodology, how experimental settle will be is that will be in field trials like I'm right now living in Kutch area, so I will make that in Kutch and Saurashtra comprehensive methods that compare the traditional method with it measurement, monitor the pest activity and crop damage. How can it reduces that crop from damages? Data types. So data collection will be from local farm for AI training, and sensor data, real-time sensor data from sensors. Performance metrics. So data accuracy will be on the basis of a visual detection, audio recognition, motion sensors, false alarm rate, response times. That's all are the matrices on the base of these. Their accuracy could be taken. Okay, what kind of expected outcome I want? That scalable solar power pest management system. So integrating of AI for a pest detection and scalability for various farm size. That could be a large or small size, whatever it is. Reduction in the crop damage. That crop damage test field. Improve the energy efficiency. So long-term automation operation in the remote areas. Contribution to a sustainability farming, so supports the sustainability practice and reduces the pest use, so that the base of it green energy or whatever we say that kind could be utilized. Significant effect. So it will be directly effect of combining the renewable energy and AI agriculture solution for the field of a smart agriculture. Yeah, their practical impact direct benefit to the farmer and in the pest management reduces the reliance on harmful chemical repellent. Sustainability for that environment friendly design using a solar energy and promote green technology for a climate resilience. So here is from my end. If any question, you can ask.
Thank you.
Rajkot, you have
Hansi?
defined in your presentation,
Uh,
uh, in your title,
uh,
you have mentioned the intelligent pest management systems integrating AI and IoT advancing
uh,
smart crop protection. But
hmm.
in the objectives, you have mentioned about the animals and database related to animals. So, what is this? Are you working
Madam,
on pest management or animal control?
that was animal detection. Animal detections, our system is based on the how can we scare that kinds of animal or birds. Uh, so that's why sometimes
See,
animals'
there is a
behavior.
difference. There is a difference
Uh,
between pest and animal.
okay.
So, what exactly you are going to uh, protect?
Okay, I wanted to protect the crops. So whatever
From
I need for it,
pest or animals?
animals and wild animals
Then
and birds.
you have mentioned pest management, intelligent pest management systems.
Okay, madam, pest management. I just want to clarify
See,
it with
you
that.
should be clear. You should be clear
Mhm.
enough what you are going to do in your work. So, what exactly you are doing at present?
Okay,
Are
I'm
you doing
going to.
PhD?
Yes, I'm doing PhD right now.
How much work you have completed your research work?
Sir, I have already make a prototype for it, and it will
But you
be
are not.
going.
But you are not clear. Your objectives are not clear to you.
Okay. Uh, ma'am,
And
I
which
will.
database you are using? Why you are using only this Zigbee protocol and Lopan protocol? Go to that slide.
Okay.
Yes,
Okay,
yes, yes.
LoRaWAN and
Yes.
ZigBee protocol.
Why
Ma'am,
only these protocols you are using?
these both protocol are widely being used in wireless communication in sensors. So
Yes,
that's
yes.
why this both. Uh,
For IoT, these protocols are used, but there are some other protocols also because as per your topic, you will have to work in field. Okay,
mm, mm.
then these protocols will be sufficient.
Yes, ma'am. How much I have worked
So
still
these
now?
protocols, will you be able to manage in
Sure,
the
madam.
transmission?
I could. Yes, sure, madam. I could.
Have
Definitely,
you
madam.
done some practical work also?
Okay, madam. Practical then. I have make a little bit video about
No,
it.
no, no,
If
no.
you allow me,
Your
if
your
you allow me,
objective
I could.
your objectives are not clear. You are
Okay.
confusing a lot. Okay. So
Okay. Madam, my
first you
research
should make
means
the clear cut
whatever.
objective for your work.
Okay.
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 So your
Sure,
paper
sure,
is
madam.
not very much up to the mark. Harshita, please note. हर्षिता आप नोट कीजिए इसे.
Yes, ma'am.
This paper is not up to the mark. Okay.
Okay, ma'am. Okay.
Next. And your title, Rajgaur, your title is also
Yes.
not clear. आपका टाइटल आपने लिखा है इंटेलिजेंट पेस्ट मैनेजमेंट सिस्टम्स इंटीग्रेटिंग एआई एंड आईओटी एडवांसिंग स्मार्ट क्रॉप प्रोटेक्शन. बहुत कंफ्यूजिंग टाइटल है आपका, बहुत लंबा कर रखा है आपने. आप इसको शॉर्ट कीजिए. आप
Madam,
स्मार्ट, आप एआई आईओटी को स्मार्ट टेक्निक्स ही होती हैं ये, ठीक है. दोनों टर्म्स भी यूज कर रहे हैं, देन यू आर यूजिंग स्मार्ट क्रॉप प्रोटेक्शन आल्सो. ओके.
okay,
तो
madam.
थोड़ा सा आपका
Your
जो भी.
valuable, madam, your valuable feedback will definitely help me. Madam, is there any things from the changes I could after that it could be published if you allow us? Means I wanted to work on that topic, so because that's also my topic also. So
Your
if you
title is
allowing
also not
something,
okay. Your title is also not okay. Okay. You will have
okay,
to
so ma'am,
revise your
I could
title
change that.
also and
Okay.
objectives and the whole content. Next, Harshita.
Thank you so much for presenting the presentation. Now I would like to invite the next presenter under the paper title Comparative Analysis of Past Security Models in Major Cloud Platforms for E-commerce. Under the paper ID 588, I request Ms. Savita Singh to take on the virtual floor.
Yes, ma'am. Is that audible, ma'am?
Yes, ma'am, you can start the presentation.
Okay. Thank you so much, ma'am. Good afternoon, respected chairperson, reviewer, and further researcher. I am Savita Singh, research scholar, Apex University, Jaipur. Today, I am presenting my research work, comparative analysis of past security model in major cloud platform for e-commerce. In recent years, e-commerce platforms have rapidly adopted platform as a services to achieve scalability, flexibility, and faster application deployment. However, this shift toward cloud-based environment has introduced critical concerns related to data security, privacy, protection, and regulatory compliance. Since e-commerce system handles sensitive customer and financial information, ensuring stored cloud security become essential. Therefore, study focus on a comparative analysis of the past security model provide cloud platform, that is AWS, Microsoft Azure, and GCP. In this slide presentation, the theoretical background and related work of the study. In cloud computing, platform as a services is positioned between infrastructure as a services and software as a services because past work in multi-tenant and abstract environment, it introduced unique security challenges. For e-commerce system, strong authentication, privacy, availability, and compliance are very important. However, most previous research has focused on general cloud security or as that is infrastructure as a service level risk, while comparative studies on past security, specifically e-commerce, are still limited. This slide explains the research methodology uses in this study. The study follow qualitative comparative research design, which means the analysis is based on description and comparison, not on numerical experiments. The research uses secondary sources that include official cloud documentation, technical reports, peer review literature. Using the information, we performed comparative evaluation of the past security model, that is AWS, Amazon Web Services, Microsoft Azure, and GCP past security. GCP is a Google Cloud platform. The assessment was carried out across 6 major security domains, that is identity and access management, data encryption and key management, application and network security, governance and compliance, incident detection and response. Finally, 5-point qualitative scoring model was applied to compare overall security capability of 3 cloud platforms for e-commerce environment. Scoring method used study. Scoring evaluation performed across 6 predefined domains. Each domain platform assessed using secondary data sources. Score is 1 to 5. 1 is very low and 5 is very strong. This slide presents the overall result of the comparative analysis. The evaluation shows AWS and Microsoft Azure achieved the highest score, that is 23, and Google Cloud Platform score 22. AWS provides high configurable and fine-grained security controls. Azure, strong governance and compliance integration. GCP, automation-focused security by default approach. That domain-wise security comparison. This slide shows the domain-wise comparison security capability across AWS, Azure, and GCP. The comparison highlights how each platform performed the identity management, encryption, governance, compliance, and incident detection and response. It helped understanding the relative strength and weakness of each cloud platform rather than only looking at the total score. This slide presents the proposed unified PaaS security framework, developed based on the comparative analysis of AWS, Azure, Google Cloud Platform. The framework combined the key submit security for all 3 platforms. Azure provide strong governance and compliance integration. Strong governance means follow proper rules, policies, and compliance follow legal, regulatory, security standard automatically. AWS provide logging and auditing capability. Logging capability, that means system record every activity, and auditing capability, this means checking security issues, misuse also. GCP, automated monitoring and rapid incident detection. Rapid automated monitoring means watch itself continuously all time. Rapid incident detection means quickly identity security problem alert. Conclusion and future work. In the conclusion, the study showed all 3 major cloud platforms provide mature PaaS security for e-commerce environment. AWS is a strong configurability, Azure in strong governance and compliance integration, GCP in automation and security by default design. No single platform is universal best. The selection depends on security needs, regularity, explorer, and operational complexity. This research also proposed unified PaaS security evaluation framework, and future work may include empirical validation, quantitative risk modeling, and extension to multi-cloud and hybrid environment. Thank you, ma'am.
Thank you so much, ma'am, for your insightful and well-articulated presentation. Now we are open to questions, if any.
Have you implemented some part of this work?
Yes, ma'am.
How much?
Ma'am, only 50 to 60%.
50 to 60%.
Yes,
But
ma'am.
you have not shown any results here.
Yes, ma'am. In this paper, I only compared 3 platforms. But my study, मैं क्या कर रही हूँ मैम, एक नेटवर्क से दूसरे नेटवर्क में पोर्ट कर रही हूँ और इसकी पास की जो सिक्योरिटी है वो मेजर कर रही हूँ नेटवर्क पोर्ट करते वक्त.
Yes, you have
Yes, ma'am.
shown the comparative results,
Yes,
but
ma'am.
how you perform this comparison?
मैम सिमुलेशन के एक सिमुलेटर बना रही
Which simulator you have used? You have not mentioned these things.
यस मैम इस पेपर में नहीं किया, बाकी मैं पाइथन लैंग्वेज का यूज करते हुए सिमुलेटर पे काम कर रही हूँ.
You should mention here.
Yes,
The title is good and in good direction. Okay.
Thank you.
Best wishes.
Thank you so much. Thank you so much, ma'am.
Now we shall proceed to our next paper. Now I would like to invite our next presenter for the day, presenting the paper titled Object Transportation Using Deep Reinforcement Learning under the paper code 469. I would like to invite Mr. P. Pavan Kumar, or co-author Sheikh Riaz, to take the virtual floor to present the paper. Mr. Sheikh Riaz, so you can start the presentation.
Yeah, good afternoon to all.
Yes, sir, you're audible.
Yeah, my screen is visible, right? Hello?
Yes, sir.
Your screen is not proper. You just share your presentation. You are sharing the whole
Screen, yeah.
screen.
Okay. ఇంటూ ఏముంది అబ్బా, నాకు అర్థం కావట్లేదా?
Yes, go to first slide. Auntie ji.
So your screen is visible. Please go to the first slide.
Yes, I'm trying to go. It was.
Harshita, we can take next 448.
Should I take the next paper?
I think it's a issue with my network. I'm unable to move the screen.
What is the issue at your end?
So it is showing it. Screen is not moving. My slide is not moving upside. It was struck.
It is an image.
No, it's a PPT only, but it was struck actually. It was not moving.
So you can try sharing the whole screen and then opening this PPT.
Till then we will take next.
Okay.
Yes, 448. Mr. Amit Patil.
Okay, ma'am. Just give me a moment to share my screen.
అది కలర్ వస్తుంది ఎందుకు
అయిపోయిందా?
అయిపోలా కంటిన్యూ చేయాలి మళ్ళీ నేను నెక్స్ట్ రమ్మన్నారు అదేమవుతుందంటే స్క్రీన్ ముందు కలర్ వస్తుంది గ్రీన్ కలర్ మూవ్ అవుతుంది.
Hello. I'm extremely sorry to inform you that I'll just need to restart my machine in order to share the screen. Can you please allow me to do the same? Hello.
Yes, take
So
your
you
time. You should ready. You know that
Yep.
between 3 to 4 you have a session. You have to present your paper. Then why you are not ready?
I'm extremely sorry. I just, because of some system changes, I'm not able to share my screen unless I restart my machine. And sorry for the inconvenience. I'll just join right back. Is that okay?
so we'll wait for some minutes.
Okay, thank you.
Mr. Sheikh Riaz, your screen is presenting. Can you please open the first?
Yes. Yes.
ఇది చెప్పు, ఇది కనిపిస్తుంది లేదు. No, that's sketchy. Sketchy. వస్తుందో లేదా అడుగు. అడుగు. అడుగు.
Hello. Hello.
Yes, sir. Your screen is
My
visible.
screen, right?
Yes, sir.
Yes, sorry for the inconvenience. There is some technical issue. I don't know what happened. Yeah. My name is Riaz. I'm working as assistant professor from Chaitanya Bharat Institute of Technology, which is located in Kotta, Andhra Pradesh. My co-authors are Pawan Kumar sir, Dr. Dasar Ramedi, Dr. Srinivasam, and Dr. Narsimaya, and Mahbub Chand are my co-authors. My title for this paper is Object Transportation using the Deep Learning methodology. So coming to abstract of my project is, so now controlling the individual robots using the deep learning process is very successful, but controlling the multi-robot system is a critical issue in non-satirical crisis. To avoid that, to avoid that, we have used a 4 different algorithms from the deep learning like DQN, DDQN, and DDPG, and DD3. These are the 4 different algorithms that have been used in this paper. DPN is a deep learning queue network algorithm, and DDQN is a double deep queue network algorithm, which is an extension for the DQN, and DDPG is an algorithm of deep deterministic policy gradient, as well as DD3 is an algorithm for twin delayed deep deterministic policy gradient algorithm. So these 4 algorithms have been used in my paper. Coming to the main motive of this paper is that how the multi-agent robots can communicate with each other and they can transport an object to the desired location or decision location. So this is the main motive of this paper. Further, we have approached a collective transport task where robots are pre-attached to each other and transported to a predeterministic location. And we measure the performance during this process, and which is very successful of the object to a goal location within a desired time frame, and highlighting the strengths and weaknesses of each algorithm. And we are mainly addressing a multi-agent reinforcement algorithm, a MARL, to engage in your robot aggregates, which refers to group of robots physically which are linked together and through mechanical connections. Right? Assume that the robots are unable to share their actions, their observations to make a partially observable environment, and the robots are able to control their wheel velocities and acquire the basic proximity sensor readings, but are unable to communicate this information directly to other robots through a message passing. The main motive is communication between the robots, a group of robots, and they are also able to sense the direction in which they are heading. That is like, are they moving towards the right? Are they moving toward the goal or not? Are they moving to backside, up front, are those things, right? If the object is moving towards or away from the goal. Use decentralizing multi-agent reinforcement algorithm as a constants based on the group during the experiments force the robots to coordinate transport. And we compare the performance of the 4 widely used algorithms to showcase the effectiveness of each approach. So means we compare the performance of the 4 algorithms what just now I explained. So we compare those algorithms for effective approach, and we show the implicit communication occurs between the robots in the form of natural push and pull action. These are the main important push and pull actions, where the robots can learn and coordinate with each other between their applications and applied force on the object and resulting movement of the transported object. The pull and push forces are implicitly modeled and learned by the agent so that they can minimize the distance of robotic aggregative over the period of training the episode, establishing an initial framework to explore the concept of predicting the next stage of the object and using it to improve the control strategies. The results shows that it helped the book. Mainly, the performance has to be increased by the robot aggregate in transporting the object to the desired location. So coming to the literature survey, we have done a survey on 3 papers mainly, so which are recent papers. The papers were Jean et al. Proposed a decentralized control frameworks, which is in 2020, and Ferry and Berman provided a comprehensive review of multi-robot control stages. We have taken some more points from these 3 papers, and we have implemented a methodology. The main methodology is that we have used 4 different algorithms in multi-agent environment. For that multi-agent environment, we have employed a multi-robot simulator. That the simulator name is ARGOS simulator. By using this simulator, we have created a multi-agent environment. By using that multi-environment, we have given the multiple samples to the robots, how the behavior of the robots, all those things. Next, obstacles are introduced to increase the complexity and challenge of the collective transport tasks. These obstacles, we have given mainly 2 obstacles in this paper. One is for cylindrical obstacle and one is for gate obstacle. So these are the 2 obstacles we have considered. What happens if these 2 obstacles are generated and following a uniform distribution and ensuring a random and diverse layout in each trail? So the algorithm what we have used is DQN algorithm. The DQN algorithm is used for mainly used to record the actions of multiple robots, but it is unstable due to non-stationary from the simulation learning. So we have implemented DQN algorithm by consisting 3 different layers. One is input layer, and one is hidden layer, and the one is output layer. So for input layer, we have taken 31 observations and representing the state of the environment. and a hidden layer with 64 neutrons and 128 neutrons, and the output layer with 9 nodes. We have considered these are the input layer and hidden layer and output layer. And DQN is a algorithm which can combines the Q learning with deep neural networks to learn the optimal policy for decision making in complex environment. So this is for DQN. Next, we have used one more algorithm, DDQN algorithm, which can be used to improve the DQN's stability by reducing the overestimations, right? So how can we overcome this overestimations? We use this algorithm, which is an extension for the DQN algorithm that addresses the issues of bias in the form of a Q values. So in DQN, it will record the Q values, so which is having high bias, and DDQN which reduce the bias happen using DQN. Next algorithm we have used DDPG. So it is a main algorithm, but actor critic algorithm for continuous control transmission learning, but it is slightly sensitive to noise and coordination errors. And next algorithm we have used is TD3 algorithm, which is an enhancement for DDPC with twins criteria and deployed updates, making it the most stable option for continuous multi-robot coordination. These are the 4 algorithms that have used, and we can check these performance of these 4 algorithms based on their results. So coming to results part, we have trained 2 models for each method. For DQN, DDQN, and DDPZ and TD3 method, we have used 2 models for each method, one consisting of 4 robots and one consisting of 8 robots, which are virtually created by a ARGOS multi-robot simulator, which is used to create a multi-agent environment. So among these, we evaluated the performance of these models by making 2 robots, 4 robots, 6 robots, and 8, and as well as 10 robots. Each model was subjected to 500 randomly generated test scenarios, with the successful criterion being the object's arrival at the goal location. So these are the different models. I mean, 2 models for each method, which having 8 robots and 4 robots. So coming to the results, we have used 2 obstacles. One is cylindrical and the gate obstacles. So these obstacles avoid the consistencies, a critical aspect of any collective or transport algorithm. In this study, we investigate model adaptability by introducing 2 types of obstacles. I said earlier, one is cylindrical obstacle and one is gate obstacle. Coming to cylindrical obstacle, so how the DQN measures based on the 2 obstacles. If you are given 2 cylindrical obstacles, DQN 0 means free environment. So how this free environment will record the performance. The performance is 64.4%, and coming to DDQN with 4 obstacles, it is like 48.8 we measure. So coming to DQN with 2 robots and 2 obstacles, it is 73.2, and 4 obstacles, it is 56.2. So these are some of the measures we observed during the training period. So coming to gate obstacles, we got 72.4.
But
Yes,
you are
yes.
past the deadline, so can you please wind up fast?
Yes, I can. Just one more slide is there. So for gate obstacle, it is DQN is 72%, DDQN is 74%, DDPZ is 77%, and TD3 is almost 76.4% we got. So coming to
Okay, Riaz, tell me one thing. So
Yes.
for your object transportation, what is the environment you are using? Because for reinforcement learning mechanism, we have to define the environment first.
Yes, so we have
What
used
exact environment you are using?
Yes, we have used a Argos multi-robot simulator environment, which have created by virtually. By using that, we have used a PyTorch deep learning library.
Virtual, you are creating the environment.
Yes.
Okay.
So that these are some of the few
And
measures we have.
how do you validate your results?
So we have used different algorithms, right? So we are based on
You are
these
using your
algorithms.
algorithms, and what is the data set you are using?
So we have used the dataset of which is created virtually. Right? This simulator ARGUS multi-robot signal will automatically generate some samples.
Yeah, some data. Okay.
Yes. So we have passed some. Yes. Shall I?
In your graph where you defined that you have used the 10 models and 4 robots. Go to that slide.
Yes.
Yes, this one, results.
Yes.
Uh, you you mentioned that you have trained 2 models for each method.
Yes. One is with 4 robots and one is with 8 robots.
Okay. So
So same thing we
have you
applied for
compared
all.
your results with, have you compared your results with the existing approaches? Because in literature review you mentioned 3 core papers you have used.
Yes.
So almost the same work have been done by those researchers.
No, they haven't used these 4 algorithms. Someone used some algorithms. So we have used these 4. Yes.
Algorithms, but the algorithms used by you and the others. So are you getting more accurate results?
Yes. So we have used these 4 algorithms for mainly check the performance, right? So we got these results based on these 4 and 8 robots, and these are the results we got.
But you have not compared it with the existing approaches.
So you mean the
So
comparison?
how can we say that your results are more accurate and the algorithms you have undertaken are good, more efficient?
Okay, in point of comparison, you asked me, right?
Yes.
So okay.
Because many authors have done this work.
Yes, but they haven't used the 4 algorithms, right? So that's why we are unable to compare with those previous existing methodologies. So we have used the 4 algorithms at a time, and we check the performance of.
Then what innovation you have did? You have just used 4 algorithms. This
Yes,
is
we have used. No. See, we used. See, traditionally we have only one robot can use a deep learning enforcement algorithm.
Multi-robot system you have
Yes,
used.
we use multi-robot system along with these 4 algorithms we have used. So this is the first we have used. And these are the results we have given.
No one else.
No. Sorry. Hello.
Yes, but you should explicitly mention this, that no other researcher have used this multi-robot model, and
No.
they have used.
Till now we have research done, right? So these paper they haven't used these 4 algorithms into them with the multi-robot system. So we thought an idea that can we use these algorithms on this one? Yes, we tried it and we got these results.
Your work is just different in the number of algorithms used.
Yes. You use, and there is a future scope also for this, so that.
But someone have used algorithm number 1, 2, 3. Someone have used 2, 3, 4, or someone have used 1, 3, 4. Then
might be.
What major difference is there? Only just 4 algorithms.
4 algorithms along with the multi-robot system.
In results, what difference you are getting?
Yes, that I mean. So if we found that,
listen, if someone have used DQN 0, DQN 2, and DDQN 0, okay, someone have used some another DDQN 2, another, but all over they have used all the algorithms. If we see, okay, and you have used in one research the 4 algorithms, then you can compare the results.
Okay. So we compare with these obstacles kind of thing. So what happened if I give the cylindrical obstacle? What happened if I give the gate obstacle to that?
Yes.
So like this, we measure based on obstacles we measure.
If the algorithms have been used by some researchers, you are saying that not all 4 algorithms they have used, but individually different researchers have used all of the four algorithms. Okay, then they
Yeah,
have
my
implemented those algorithms, and
hello.
your work is more uh, giving more accurate results.
Yes, more how the performance has been increased.
But
Between
you have
more.
not shown.
No, we used only two different obstacles based on this. We pass these obstacles to the robots. So how
Your
this
paper,
algorithm?
and
Sorry, your voice is breaking.
you update your paper accordingly and resubmit for the publication.
Okay, with comparison results, right?
Yes.
Okay, so
Yes.
shall I
Next.
conclude? Shall I conclude? Conclusion?
Yeah,
Can you say?
you have concluded. Next.
Thank you so much, Sir.
Yeah,
Now,
thanks
I would
for
like to,
yeah, thanks for giving the time. Thank you. Thanks so much.
I would like to invite Amit sir to present his paper under paper ID 448.
Sure, thank you. Uh, I hope my screen is visible.
Yes.
Okay, thank you for the confirmation. Uh, Sorry for the inconvenience before. I am Amit Patil, a student of MEIT from Thakur College of Engineering and Technology, Mumbai, and a senior software engineer working in Here Technologies, Mumbai. Uh, I'm going to present my paper on real-time multi-view fire detection using YOLO for on-device edge deployment under the guidance of Dr. Rajesh Bansode, HOD of IT department from Thakur College of Engineering, Mumbai. So to give the brief introduction about this research is, we are developing a fire detection system. So in the era of smart cities, fire detection is a very useful use case which we need to improve. As we know, the fire events can cause human life, infrastructure, as well as
Yes.
environmental
Yes. Yes.
losses.
All these things. What is YOLO?
YOLO is you only live once object detector model that we have used in order to detect the fire events through the camera streams.
So this YOLO is using multi-view fire detection.
Yes, right.
It is already working.
Yes, ma'am.
Okay.
So the
Then
objective, sorry, I'm just giving some information ahead, but the objective here is we are presenting a model that will be able to detect the fire events from the multiple angles. So in the current literature, most of the systems are focused on the single view, like only a aerial view capturing from the drones or UAV devices, or only a camera front view or the surveillance camera views. Okay, so that's why it's only focusing on the one single view, but we are proposing a multi-view
but
approach.
YOLO is doing na.
Yes, YOLO is doing.
देन आप कैसे कह सकते हैं कि सिर्फ सिंगल व्यू से हो रहा है? योलो तो मल्टी व्यू डिटेक्शन कर रहा है ना.
As in, YOLO is focused on the data set, how we are training it. So it's not just about the view, it's about the data set.
It's about the data set.
Yep.
Okay. No. Yes, continue with your presentation.
Yeah. So the objective here is to develop a feasible system which will overcome the limitations of the existing fire detection systems and make it a feasible and scalable so that it can be easily deployable on a variety of devices for the better infrastructure and better event monitoring that can be utilized. So to talk about the existing approaches, in the existing systems, the commonly and most powerful approaches that are used for detection of fire events are the sensor-based alarms, cloud-based vision solutions, and single-view detectors or classifiers, as I just mentioned. So if we talk about the sensor-based applications, they're mainly dependent on the various hardware and sensors like temperature sensors or the smoke sensors in order to detect the fire events. So it has a more maintenance cost and requires a dedicated hardware for the detection of such events. So it can be a complex to deploy in the real world scenarios, and often requires a manual verification to ensure that we are not triggering a false alarm. And in for that verification, we need to present in the location because of the unavailability of the visual context. So that is the limitation of the sensor based alarms. Moving forward, we have a powerful cloud-based solutions which can detect the fire events effectively using the camera feeds or the image video streams. But the drawback here is that we need a powerful service, and we need a strong communication link between the devices that is capturing the stream and the servers which are processing this stream to detect the fire events. So so there is a high dependency on the bandwidth requirement as well as the data requirement as well to share over the network. On the other hand, we have a ML solutions which basically trains a model to detect this fire events from the images, as I said. But existing systems are mainly focused on the single view, and they focus on one specific domain itself. So there is a huge requirement of developing a feasible solution which can basically deployed on the variety of devices, focusing from the multiple views. So one single solution can be deployed on the variety of devices to detect the fire events. So considering this scalability issue, we have designed a system which can train a model which can capture the fire events in the multiple views, and we can deploy that on the low resource constraint edge devices. So on the same lines, the existing approaches that we say that has limitation that we just discussed of multi-view generalization. Like the existing solutions are very focused to the same domain, and it's very difficult to generalize them in the multiple domains and multiple contexts. Then small target sensitivity. So the often the images captured from the aerial view are very small. So it's very difficult to capture those small fire events. Because this small events itself will going to be expand more and harm more. So early detection of small targets is important. Then there are some fire-like distractors, like some the reflections of the light or some bright objects that can create a illumination of the fire. So it's often can be misdetected as a fire. So it is important to segregate this kind of distractors from the actual fire events to reduce the false alarms. And there is important aspects of feasibility to deploy it on the edge devices. So as we see, when the servers are involved, there is high dependency of the bandwidth requirements and latency, as well as servers requires a more processing power. We need a solution that can be easily deployed on the low resource devices, like our Android phones or Jetson Nanos, like small edge devices, so that it can detect these events visibly and report them for the further monitoring and response.
So what you will do for this?
So in order to tackle that, we have proposed a solution which basically trains a model using a YOLO architecture and converts them into the compatible format for the various devices. So we will train a model once, but it will be compatible to convert into the different format to deploy on the different devices. For the sake of demonstration, we have converted this model into a TF-Lite format which can run on Android devices. So we have created an app which can run on a live stream and detect a fire events and notify us about that. So that is just for the demonstration purpose. So such kind of apps can be deployed on the monitoring vehicles like our government vehicles like ambulances or police petroleum vehicles, or the routine vehicles that go on roads, and they can detect such events and automatically report them. That is the largest scope of this project. But yeah, for the demonstration, we have used the Android application. Such converted model can deployed on other devices, edge devices as well, like the surveillance cameras or drones for the continuous monitoring. So the proposed system is consists of this architecture, which involves the first step of data collection, going forward some data pre-processing and filtering, then model training and evaluation, and convert the model into the appropriate format for the edge deployment. So to talk more about these steps in detail, first data collection includes gathering of images and their annotations for the fire events from the open source data sets. So we have collected various open source data sets from the multiple domains and combined them together. We perform some cleanups to avoid some noisy samples and make sure our data quality is good. At the same time, we have extracted some raw images as well, images and videos as well from the different sources, and extracted the frames from that to manually annotate and use them from the model training. So the focus was to gather the data from different domains and different devices, like capturing data from dash cams or UAV device, surveillance cameras. So it will include the images from the different angles, as you can see in this image, and annotate them for the model training.
So can you please wind up fast? Yeah, past the deadline.
Yep, sure. Further, we process this data to make sure add some augmentations to replicate the various real-time scenarios, as we said, in order to generate the multi-view real-life scenarios, and actually train the model with this enhanced data set with the optimized camera parameters. Optimized model parameters that are shown in this table. The objective was to basically generate a model which is feasible to capture the fire events from the multiple angles, and making sure that model is small enough so that we can deploy it in the low resource edge devices. So as I said, we have created an Android app that looks something like this, which can run on the live camera stream, and if it detects some fire events, it will give us the bounding box overlay to show whether there is a fire event.
Which version of YOLO you are going to use?
So for this, we have used YOLO 11S by comparing its performance.
Okay.
So moving about talking about the results, quantitative and qualitative results. This screen you can see in the precision recall and MAP scores for this model that we have trained. We have achieved a pretty good precision of 83% for the fire detections, and the recall is little low of 71%. That means we are able to detect most of the fire events, but there is still room of improvements to increase this recall.
So you will collect the data, then train that data,
Mhm.
and you will link that data with YOLO 11.
Yes, right.
This is exactly the model.
Yes, correct. We use a transfer learning approach to train this new data set with the YOLO model.
But in your approach, you are using multi-view,
Yes, right.
because many of the researchers have uh, done this. They
Yes, right.
have,
The single domain is used
yes,
multiple times, but
uh,
yeah,
single
but not
domain,
the multi-view.
but not the multiple.
Yeah,
Okay, it is
yeah.
good.
Mhm.
Okay, best of luck.
Yep. Thank you, ma'am. So to conclude, I think we have seen pretty good results, but there is still scope of improvements that we can achieve, and have a real world testing to make sure this detection system is appropriate, because it's a really critical system in the actual real world use cases. And the future work can be to integrate this with the emergency systems, emergency management systems, so that we can reduce the gap to detect such events and provide the response to
So,
the
Amit, how this work will be helpful in your this corporate work?
Actually, not exactly this use case, but we are using YOLO model to detect various road signs. So I'm working in the Here Maps, which basically generates the maps just like our Google Maps.
Okay.
So there, in order to capture the various road signs and keep it up to date, we capture the live streams and extract the road signs from that and
Okay,
use
one
that.
more feature will be added to the.
Yes, right.
Okay, thank you. Okay.
Yep. Thank you.
Thank you so much, Amit, for such an insightful and well articulated presentation. And with that, we conclude today's paper presentation session at UNI-TEAS. And we sincerely thank all of your presenters for their valuable contribution and our audience for their active participation. A special thanks to our session chair for guiding the discussion with clarity and depth. Now, I would like to request all the participants to kindly switch on their cameras as we will take a virtual photograph to capture this memorable session.
But all presenters are not here.
Yes, ma'am. Them left.
Only last one, 448 is present here.
Yeah, rest all left.
But that's fine. We'll take the virtual photograph fast only.
Yes. Am I visible? No.
No, ma'am, you're not visible.
What happened to my camera? Yes.
Yes, ma'am, you're visible. We'll take the screenshot. Thank you so much. Thank you all for, and we are looking forward to seeing you in the next session. Have a great day, Ed.
Thank you, Ashita.
Thank you so
Thank you
much.
so much. Bye, everyone.